The other member of this genus that we'll talk about is Bacillus cereus. This is most often seen as a foodborne illness, and there are two manifestations of disease. There is the emetic form, where the major symptom is vomiting, and generally is caused by ingestion of toxins. And then there's the diarrheal form, which is most often associated with actual infection, so the bacteria establishing an infection in the gut. So there are two different enterotoxins. There's a heat-stable toxin, which causes the emetic form, the vomiting form. And again, heat-stable means the bacteria could have been replicating on your food. Rice is a really common food that this tends to be on. And then, you nuke it before you eat it, and you kill all the bacteria because you microwaved it or heated it up in some way. But the toxin is heat-stable, so it's not destroyed by the heating in the microwave. And so once it encounters the appropriate tissues, it can lead to that vomiting. The diarrheal form, the toxin is heat labile. So this means that if the toxin was on your food and you heated your food, you would destroy the toxin. So generally what we're looking at in this case is the bacterium has gotten in and established an infection in the GI tract, started producing that toxin, and so then you get these symptoms. And again, if you look at the time course, the emetic form, within 6 hours, the average is 2 hours. That's about how long it takes for the toxin to hit your tissues and for you to start vomiting. And then because you don't have an actual infection, it's just an intoxication. After you clear the toxin, your symptoms generally go away. With the diarrheal form, it takes longer to establish the onset of symptoms because it takes longer for the bacteria to get in there and set up camp and begin producing their toxins. But that means it also takes longer to clear because you actually need to get the bacteria out of the body too. So the bacteria need to get out and stop producing toxin, and then you need to clear out the rest of the toxin. So it's a longer course of disease. And that's going to be a really critical thing for you all to be able to differentiate is an intoxication, which is just the ingestion of toxin that usually will cause vomiting within a few hours, and a foodborne infection where the bacteria establish an infection in the gut and cause disease. And again, that takes longer than the intoxication. Bacillus cereus can also cause ocular disease if the bacteria get into the eye. There are 3 toxins that it can produce that will cause ocular disease: necrotic toxin, aceriolysine, and phospholipase C, which lyse host cells, and that can lead to rapid destruction of the eye. In immune-compromised patients, this bacteria can set up an infection in the lungs that can mimic what anthrax looks like. But again, with that pneumonia, we're looking more at patients who are immune-compromised. And this headline I thought was kind of interesting. A strange type of anthrax is killing chimpanzees. And it turns out it's actually Bacillus cereus that had somehow acquired the anthrax toxin plasmids, right? The genes to produce anthrax toxin. So these chimpanzees effectively did have anthrax because they had the edema and cell destruction mediated by anthrax toxins, but those anthrax toxins were being carried by Bacillus cereus. So for human medicine, or even for animal medicine, I guess, the idea that toxins are on plasmids can be that some toxins are on plasmids can be very scary, because if those toxins, those plasmids, right, can be transferred from one bacterium to another, you could make a more common bacteria that typically was less pathogenic, you could make that bacterium very, very dangerous all of a sudden. So that's something to think about too, the consideration of these mobile genetic elements, how interactions in the microbiome could mediate transferring mobile genetic elements from one cell to another, from one species to another, and make a formerly less dangerous organism far more pathogenic. Bacillus cereus, and really Most Bacillus species, even anthrax, are found in the soil. But Bacillus cereus can be cultured from individuals or from food that has been associated with causing illness. So again, if a patient has diarrhea, you can often isolate Bacillus cereus from a stool sample. If everybody ate the same, the diarrheal form is usually associated with like meat and potatoes, or vegetables, meat and vegetables. So if everybody ate the same kind of food, off the same plates, you can probably isolate the bacterium from there too. As we saw on the first slide about the gastrointestinal infection, it's self-limiting. Almost nobody is going to have serious complications. Haha, no pun intended, right? Bacillus cereus and serious complications. Almost every patient is going to be able to clear it. And that's great. It might suck for 24 to 36 hours while you have diarrhea, but at the end of the day, or the end of the second day, you're going to be on the road to recovery. But these ocular infections caused by Bacillus cereus are very, very dangerous and must be treated promptly. There are a number of antibiotics that can be used to treat Bacillus infections. We don't tend to see a lot of antibiotic resistance in Bacillus because it is not a very common infection, especially like Bacillus anthracis. But even Bacillus cereus is not one that you commonly would go to get treated. If you have diarrhea for 24 hours, the chance that you're going to go to the doctor is very, very slim. The chance that you could get a doctor's appointment within that 24 hours is pretty much non-existent. So because these bacteria are most often self-limiting infections, they're not constantly exposed to antibiotics, we don't see high levels of antibiotic resistance.